Now, I'll give you first the idea what we have just done in the previous session, what we have covered till now. So first, we have covered some of the Python basics. We have covered environment setup. Environment setup. Environment setup means installing the softwares which are required for writing the programming, whatever program you want to write for that. So I talked about two of the environments. One you have to install on your laptop, on your systems. If you can't install, I have discussed an alternative that will be on the internet that you can use. So two environments I've discussed. You can go through that and do the installation if you want to attend more of the sessions. So Python basics, environment setup. Then I talked about some of the data types. We were discussing about some advanced data types which are there in Python, which help us do something, which help us write some program. So till now we have discussed about something called as strings, and we have discussed about lists. These are the concepts we have covered till now. And also with the programming with Python basics, I have discussed how these things affect our memory, how they are stored in the memory, how much space they take, and what things you can do with these concepts. Now, from today's session, in this week, we'll be discussing about some of the things, which will be, first, we'll be talking about tuples. So like strings and list, this is another data type which helps us do something. We'll start with that. And after tuples, we'll talk about something called as sets. Then we'll talk about dictionaries. Then we'll talk about conditional statements. If you're writing program, you have to use conditional statement multiple times. So we'll be talking about conditional statements and the loops concept. This will be our focus for this week. And in upcoming weeks, we'll be talking about object-oriented programming and then functions, how to make functions. And we'll be talking about a problem-solving session. We'll be having a problem-solving session. In problem-solving session, I'll walk you through how to think about a problem. Many of you, if you want to do the code, you might get scared because you are not able to understand the logic. You are not able to solve a simple program if you try that. So many leave the programming just because of that, but it is not something to be scared of. It's a simple thing. It happens to everyone. It's just about the practice. But I will give you some idea using which you can follow through and you can access, you can attempt those questions little more in more organized manner. So these problem solving sessions also will take, and we'll try to have some questions, some programming questions. We'll go through those concepts. How do we apply the logic? How do things happen? How to break down a problem into smaller components to solve them one by one. These are the things we'll talk about. But for today's session, let's talk about the concept first. This is the tuples. In previous session, we talked about string and list. Those who have attended the previous one must have understood the basics of that. Now, let's see what things are to be discussed in tuples. Now, tuple is a data type which is very, very similar to a list. In list, we have seen that we can put multiple data together. So if I create a list, it was inside these square brackets. And inside these square brackets, I can have multiple values together. I can have 10, 20, and Python. Whatever type of data we want to have, we can have a collection of that in one particular advanced data type, which is list. We are seeing that. Now, tuple is just a data type very similar to list. What it does, we can have all the functionality. The way we created a list, the same way we create a tuple also. What will be the difference? The difference will be that tuple will be inside these round brackets. The list was inside these square brackets, but the tuples will be inside these round brackets. And the main important property that separates tuple and a list is the property of immutability. So I told you that lists are mutable. Mutable means they can be changed. Changing means you can add data to the list once you have created it. You can delete some data from the list, you can replace some data from the list. These are mutability property. Tuple is a very similar data type like a list. It is created using these round brackets, and they are immutable. Immutable means whatever we could have done, like adding the more data, deleting data, and replacing values, that I can't perform in tuples. So once the tuples are created, once you have given some values inside this tuple, it can't be changed. It will be there as it is forever. Nothing can be added, nothing can be deleted, nothing can be replaced. So tuples are immutable. Let's talk about all of the things, how to create a tuple and how to perform the operations, whichever is allowed to us. Let's talk about it. I hope you must have seen the previous sessions. We have uploaded the videos on the YouTube also. There also you can practice. You can have the Google Classroom also. There also you can practice. Let's create our first tuple. Now, to create a tuple, I can say tuple1 is equal to, it's very similar to list. We were saying that I can have multiple values inside. We just had a list inside the square brackets. Tuple will be inside this round bracket. 10, 20, 30, 40. This is one tuple you can create. Second could be, you can have a tuple 2 is equal to, you can have a tuple of strings also. The text value you can have in the tuples. So I can say Python maths data machine. This can be another tuple. This tuple is a tuple of all strings, all text. This also I can have. I can have tuple 3, which can have all the decimal values or the float values. I can say 100.2. This is going to be there. So these are basic tuples. You can create a tuple of all integers, tuple of all string values, and a tuple of all the float values. Now, we have seen that a tuple can have multiple data types together. So what do we mean by that? I can have 10, 20, 30. Also, in the same tuple, I can have 40.3, 50.6. These some float values I can have. Also, I can have the text values. Also, we can have another tuple inside. So I can say 30, 40, 50. It's a tuple. It's a small tuple which is inside this tuple 4. So we can have integers, we can have float value, we can have text, we can have another tuple. Also, since we now know about the list, we can have a list also inside of this. So now you can understand the power and flexibility of these tuples. Same way, if you just remove these round brackets from the start and end, and if you say something like this is a list. But if you replace them with a round bracket, that will be called as a tuple. So how they are different? The one property I told you about, that tuples are immutable. Once you create the tuple, you can't change them. But once you create a list, you can change them. But there is one very interesting thing you will understand here. And for understanding that, see very carefully. What can we do? So first we'll talk about that property. So to understand that property, we need to talk about indexing and slicing concept. Indexing, we have understood what we do with indexing. It's just a way to access data from a tuple, from a list, from a set, from a dictionary, whatever it is, we do that. Let's talk about that. I want to access some data from tuple 4. If I want to access this 50.6, what can we do? What should we write here? We should write the name of the data tuple 4 and inside a number. What should be that number? Tell me both the numbers using the forward and backward indexing, both the numbers. Very quickly, those who have attended the previous sessions. Anyone? 50.6 we want to access. Okay, one. I got one answer. Anyone else? So what we can do in this case, to access a data from any data type, like from the string, from the list, from the tuple that we have discussed, we need to do that. So if I want to access 10 from this tuple 4, okay, I want to access 10 from the tuple 4, I'll have their index numbers. There is something called as index number. We use them. So we say 0, 1, 2, 3, 4, 5, 6, 7, and 8. There are 8 data types in this. Okay, 8 values are there basically. The first is 10, 20, 30, 40.3, 50.6. These are the values. If I want to access this 50.6, I will use this index value 4. Index value start from 0, and this is the fourth value. Now, from the backward, if I want to access the same data, it will start from -1, -2, -3, -4, -5, -6, -7. Those who have not seen the previous videos, don't worry. If you go through that, you will understand. But for now, try to understand. You'll get the idea. So for accessing 50.6, I have two options: 4, -5. Now, let's see that. If I say 4, I'll be able to access 50. If I say here -5, I'll be able to access -50.6. That is something we can do. If I want to access this list, what should we write now for accessing this list? This list is complete one data. It's one value for this tuple 4. If you can see here, it looks like a collection of elements. It has multiple values inside this list. But when you take a look at this complete list as a total, it is one value for tuple 4. So to access that, we have two options. Either I can write 8, or I can write -1. This is the concept. So I can go to any value and I can access that from the tuple 4. Now, if I create a list, if I say list 4, and I'll take the same values and I put that inside this square brackets. Same values I've taken. Now, in this, what is the difference here? Let me show the difference first. The immutability property I was talking about. So if I say now 8, I have got this data 11, 12, 13 from the list 4. Now, if you want to access this value, you have accessed it, and we have seen that we can change it. I say that go to list 4, go to index number 8, and give a new value there. I want new value to be 90. So what will happen? If you now check the list, it has been changed. So it has been replaced by the new data I have given. So I've given the name of the list, location, and the new value replaced. But if I try same thing in the tuple, let's see whether it will happen or not. So if I say go to tuple 8 and create 90, it will say error. It will give us an error and stop the execution. What does this mean? Tuple object does not support item assignment. Assignment means this operation. You can't assign a new value to the tuple once it has been created. But in the list, you can do such an operation. So first, we are verifying that property that list can't be changed. It is immutable. Again, after that, we will try to add some values, remove some values, and we'll check whether it can happen or not. But for now, replacing did not work. So one property we verified. Okay, so I'll remove this for now. This idea is clear. This is how we create a tuple. That's the thing. Now, the properties of the tuple we need to talk about. The properties are accessing elements in a tuple. So here we'll go little depth, and I need to explain something about this mutability and immutability. See this thing very carefully. You'll get a lots of idea about what I was talking about. So if I say here, I have this tuple 4, and if I go to location number 8, this is the value. 11, 12, 13, and it's a list. You can see very easily. If I try such an operation, it was not working. I understand it is not working because it can't replace an element from a tuple. Understandable. But if I want to access this 13, how do I access that? Very quickly, for those of you who can answer, just answer that quickly. If I want to access this value, 13, very quickly. So first I will go to this list. This list is at location number 8. Then I need to give another square bracket, if you remember. What will be 13 now? Okay, using negative indexing, we can say -1, -1, correct. And using positive indexing, I can say 8 and 0, 1, 2. I need to give 2 index values to get to this 13. Let's try whether it is working or not. I'm just getting one answer from Ronak. Anyone else? Please be engaged. That way you are going to learn. Whatever it is, you don't have to be correct. Just try something. We have to make it interactive. Yeah, that is also correct. Now we are getting the answer. Okay. See, we have 8 and we have 2. I said that I'll be able to reach 13. Now tell me, look at this very carefully and tell me, can I change this value? Can I replace 13 with something? See very carefully, try to remember all the properties of list and tuple. Can we change it? Think about that. I can't change this complete list. At the place of this, I can't say that remove this complete list and put 90 here. But can I change something from inside? If I want to replace 11, 12, and 13 with something, can I do that? Just an answer. One I've got. Anyone else? No one? Okay. Let's talk about this. And this will be very important to understand. See, we were talking about two things. First, I told you that lists are mutable. You can change something inside the list. Whenever you are inside the list, you can change something. Whenever you are inside this strings and tuple, you can't change something. They are immutable. Once a string is created, you can't change that. Once a tuple is created, you can't change that. Remember this property. Lists are mutable, strings and tuple are immutable. List can be changed, strings and tuple can't be changed. Let's understand that. What do we mean by this? So many people have this confusion, but today you're going to clear this confusion. See, what is this? 13. 13 is an element of this list, or is it an element of tuple? Because if you look at 13, it is present inside this list. It's a small list where 11, 12, and 13 is there. And 13 is an element of a list. Okay, I'll talk about that. Don't worry. I'll show you one example also. See, we have 13 here, correct? 13 is a part of this list. It is not directly a part of tuple. It is directly a part of the list. So wherever you see a list, it can be inside a tuple, it can be inside a dictionary. We'll talk about other data types. Wherever you see a list, it will hold its property. Now, I was talking about that if you have a tuple created inside and you have a list, it's a tuple, the round bracket, and it's a list inside. This list, this whole structure that you see, this complete structure, it is a part of the tuple. Correct? It's a part of the tuple. But the values inside the list is not the part of the tuple. It is the part of the list only. So I can go inside and change this value. I can go inside this list and I can add some values also. But those things we'll see later. Let's see whether it is working or not. If I go to tuple 4, 8, and 2, and at the place of 13, if I say 31, and let's check now what is tuple 4. You can see The 13 has been replaced by 31. It is going to work. Now, how to access T here? There is this Python word and I have to access T. What do we do in this case? Once you understand these small concepts, it will be very easy for you to use Python. Python looks very complex because of so many small things are there, but you need to understand them very properly. Then you will not forget this. If I have to access T, what should we do now first? I have to access this whole text first. Once I access this whole text, it's a string. It's a part of tuple, but if I access this string, I can go inside this string and access T now. So first I have to access this string. How do I access this string? I need to say tuple 4 and I have a bracket 0, 1, 2, 3, 4, 5. When I say 5, I'll be able to access Python, this text. Once I am able to access Python, I can just write I can go inside 0, 1, 2, 3, 4, 5. So 0, 1, 2, T is present at 2. Okay, I need to write tuple 4, 5, and 2. This way, I'll be able to access T, the character T. Understanding, everyone? This is the concept. Now, if I have to access 40 from this tuple, this is a small tuple inside the bigger tuple. If I have to access 40 from here, what will I do? So 5, 6, 7. I have to access this complete tuple first, where we have 30, 40, and 50. So I'll say tuple of 4, and I will say 7, and it's 0, 1. This is item number 1. If I say 1, I'll be able to access this. Now tell me, can I replace this 40 with something else? See carefully, can I replace this 40? Anyone? Cannot. Can. Okay. Think. Anyone more? Can we change this 40? I got 2 yes and 1 no. Since it's a tuple. Correct, correct. Anyone else want to try? See carefully. Okay. I've got some yes, I've got some no. Let's talk about that. See, I was telling you that this 13 was a part of what? This 13 was part of this list. It was an element of the list. So if there is an element of the list that can be modified, that can be deleted also, replaced also, these two things can happen with this element. But this value is a part of this small tuple. It is not part of directly this bigger tuple, but it is the part of this small tuple, this one. So 40 is an element of a tuple. I can't replace this. I can't change anything from this tuple. 30, 40, 50 is there. I can't do anything. Correct? So let me try that. So we have this tuple 4. And if I go here, I can say -2, or I can say 7 also. -2 is there. And if I try 0 and 1, 40. Let us try it. Can it happen? And if I say instead of 40, we have 45, will give us an error. Correct? This is the concept. Similar way, I can go to this place. I can go to Python, which was 0, 1, 2, 3, 4, 5. If I go here 5 and 2, what will I get? T. Can I replace this T now with something? I can't, because it's a part of the text. This Python is a string and T is a part of this string. Strings also cannot be changed. I can't go and inside of the string and change that. But now, this you have understood, correct? There was this list 4. List 4. Now in this list 4, tell me, can I replace this word Python, complete word Python, with something else? I want to replace this complete word. Can I replace this in a list? I'm not talking about a tuple now, because in tuple we can't replace any of the values. Can we replace this Python word? this total. I'm not talking about any of the characters inside, just this whole thing. Let's see. So to replace Python, I'll have to go to location number 5. This is my Python. And instead of that, I can say another word. I can say another number also that will replace this. Let's say JavaScript. And if I run this, it has done. And when we check list 4, correct? What has just happened? We said that we can't change a string. So when can we not change a string? When we are going inside that string. If you are inside, I can't replace P, I can't replace Y, I can't replace T, H, O, N. These characters I can't change. But when I look at the Python, this word, this is an element for list 4. And if anything is an element of a list, it can be replaced. The total data will be replaced. But if I want to go inside and replace T with something, that won't be done. So these are some of the small details you need to understand about mutability and immutability. Wherever string is, it will hold its property. Wherever you have a list, it will hold its property. It does not matter if a list is inside a tuple. So it does not matter a string is inside of a tuple or a list. It will hold its property. Correct? Okay. These were the things we understood. And I hope you must have got the idea. So this concept that we apply when we write to index value, it is called double indexing. And you can have triple indexing also. You can use. Now, this was the indexing concept. If you want to do slicing also will be very simple in the case of a tuple. Let's talk about slicing. So in the slicing, I can write some locations. Let's say I write 2 to 6. So values from location 2 to 5 will be selected. 30, 40.3, 50.6 Python. They are the elements at those locations. They can be accessed. Now, this was indexing and slicing. How to access the data. You can access the data, but can't change the value inside the data. So you can see here, changing a tuple is not possible. You will get a type error. Tuple does not support item assignment. This is what it is going to change, tell you. Now you can do one operation like this. You can have, there was this tuple 1 we have created. There was this tuple 2 we have created. So we can do something like this. We can say tuple 1 plus tuple 2. Okay, tuple 1 plus tuple 2. What will happen? So when we say tuple 1 plus tuple 2, the values will be taken from here and the values will be taken from here and they will be put together. This process is called a concatenation process, putting the values together from two different data types. Now, sorry, from two data, not two different data types, from two data. So we have tuple 1, tuple 2. I have done this. Now you say that a tuple can't be changed. So how this is happening? So now what is happening is, after running this operation, when you check your tuple 1, it is not changed. Nothing has happened to tuple 1. And when you check tuple 2, nothing has happened to tuple 2 also. They are as it is. So when you have done this operation, tuple 1 plus tuple 2, the values were taken from this tuple 1 and the values were taken and a new tuple was created in which this value, these values were put up and it's a new tuple. So original ones are not going to be changed when you do such an operation. And that is the way you can extend a tuple to become bigger. And what I can do now, I can save that into a new tuple, that is tuple 3. And after adding these two values, I got a new tuple, which is tuple 3. So this is one operation you can perform, tuple 1 plus tuple 2. This is how you can add elements to a tuple. This is the only operation. There is no other way to add tuple. So like in the previous one, we have used the extend method, the append method correctly. If you remember, we used extend, we used append to add values to the list, but we can't use them here. Now, this was about changing a tuple. So tuple can't be changed. Let's talk about tuple deletion. So in tuple deletion, there is only one way you can delete a tuple, delete something from the tuple. What is that way? The way is You can't delete something from inside the tuple. Correct? So what option we have? We have this del keyword. There is only one option to delete for using delete uh, operation in tuple. So we can say delete and tuple3. What it will do, it will delete the complete tuple along with the structure of the tuple that will be completely gone from the memory. And if you search for tuple3, won't be visible. It just says name tuple3 is not defined. It means that tuple3 is not there in the memory anywhere. So there is this only one option we can use, del complete tuple. We can't change, we can't delete anything from inside the tuple. Next operation is this. Let's see what else we can do. We can count something. So we were counting what values are there, which elements are there, and how many times they are present inside the list. Same way we can count the elements, how many times they are present inside the tuple. Let's see. So what we can do now, we have our tuple4. And inside this tuple4, if you want to count something, tuple4.count. And how many times 20 is there inside this tuple4? Only one time. So it will tell one. How many times this Python word is there in tuple4? Only one time. If it was 2 times, it will give you that count. It's a very small thing. Take the tuple.count, the word or the element. Same way we have done in list also. The name of list dot count, whatever you want to search for that. The next is tuple indexing. What we do in tuple indexing? We can find out the index value for any tuple. If you want to do slicing of something in a tuple, you first have to know the location. You first have to know their index numbers. That is the only way you can do the slicing. So if we talk about tuple4, and if I want to access this data, this much to this much, what should I know first? I should know their starting value. So what will I do? I'll say tuple4 dot index, and for which one? 50.6. So our starting index is 50 number 4. And where we have to go? Till Java we have to go. So now I can say tuple4 dot index and of Java. What is the stopping location? 6. Now if we want to do the slicing here, what should we do? We will just say tuple4 and we will say location number 4 to 6 or 7, 7. So when we say tuple4, 4 to 7, 50.6, Python and Java. So you don't need to calculate there, or you don't need to search for index numbers manually. You can just use this dot index and give the element. It will start search for this and it will search for this. Wherever you want to stop, your stopping place is 6. So you will just write one place more than that. This was about tuple indexing. Take a look at it. If anyone has any question, just do let me know. After tuple indexing, the next concept is tuple membership. So membership is just going to find out whether something is present in that or not. This we were searching in string also, we were searching in list also. Same we can search in tuple also. So if I have tuple4, if I want to search something, whether it is present inside this or not, I don't want to know its index location. I just want to know whether it is present or not. So I can say 70 in tuple4. Whether this number 70, this integer 70 is present in tuple4 or not. So it will tell you false. And the opposite of that is 70 not in tuple4. You're saying 70 not present in tuple4? True, because 70 is not present in tuple. If you want to search whether the word Java is present in tuple4, you can search for that. Sorry. It is true. So you can check whether something is present inside that data or not. You can check in list also, string also, tuple, same thing. that is about tuple membership. For membership, you have these keywords in and not in. Just write the element you want to search in the name of the data. Now, the next operation is you don't have much options to perform in tuple because most of the things are restricted. It is immutable, so you can't add values, you can't delete some values, you can't replace something. So most of the things are restricted. The many of the things we saw in the list, most of the things we can't perform in the tuple. So where can we use tuple? Can someone think of any operation or any use case where can we use any simple use case to store some data? What kind of data that can be? Anything you can think of? Where can we use this tuple with its property where it will be more useful? So now we were talking about that database we can create for users. That database where we have the username and we have the password. Now, if you're taking username of multiple users, what will you do? You can make a list of multiple usernames. If let's say on your website, 100 people are coming, 100 users are coming and they are logging on and they are making their profiles. So you know that all of the 100 people, they have their username, unique username. So what will you do? You will just make a list and you can have the usernames inside. And also for the password, you can have that inside this list, all the password, the collection of all the passwords. But what is the problem here? Since this list is a type of data which can be changed, then there is a risk that the usernames which are there inside can be deleted also by mistake by doing any operations. So they can be deleted, they can be replaced, and some extra username can be added which we don't want to add because list allow those operations. What we should do now? We should now convert this list to a tuple. So we should store that username and password in the form of a tuple because once you have created a tuple of that data, you can't change anything from inside. So you will be sure that it is secure once that is created. Correct? So that is one very small use case that you can think of. Now, there is a method using which you can, let me show you. There is a method using which you can change a list to a tuple. Let's say you have got a list. Let's say I have got a list of passwords. In this, passwords are 1, 2, 3, 4. I'm just giving like a text 4, 5, 6, 7. The passwords can be anything. And let's say I've got this as a list. How to convert that as a tuple? I'll say save, and I will say tuple, and inside I'll say passwords. So this tuple is a keyword. What it will do, it will take that list and it will convert that into a tuple. So if I check my save pass, what does it look like? So we had a list earlier of all of these elements. What I said convert that as a tuple. So I had a tuple and inside I give something. So how does it look like? It is the same operation where we try to change the data type. Like when we said int and when we said inside there was a float value 30.4. What was happening? This float was converted as a int. The same operation we can perform like this also. And not only this, you can convert a tuple into list back. What you have to say now? You have to say pass2 is equal to list of save pass. Save pass is a variable in which you have the data as a tuple. So it's basically a tuple. So when I say pass2 and when I check my pass2, I basically changes this tuple to a list by using this keyword list. And when I use this keyword tuple, I have changed a list into a tuple. This also you should remember, this will be needed for doing some operations. So you can play around with these data types and interchangeably convert that. Now, so we have seen safe password, safe password, safe pass to, all the things we have seen. There is one interesting type of data which is called sets. I will tell you what you can do with the sets. Okay, but before that, let us talk about just 2-3 more things which are there. So you can check the length of a tuple. You can just say length of tuple 4. It will tell you how many elements are there inside. So if 9 elements are there, their index number will start from 0, will go till 8. Total 9 elements are there. Likewise, this is the tuple length. Can you do the sorting in the tuple? Let's see how can you do the sorting. So for that, I'll just create a new one to show you that. 30, 40. So I have 100, see, 45, 58, 30. This is the tuple I have. How can we sort it? So in the case of list, we talked about two things. We talked about this keyword sorted. What was this keyword sorted doing? It was sorting the list, but it was not sorting the original list. It was giving us a new one, a new list in which it had the sorted data. The next operation was we had the name of list dot sort. So whatever, let's say the name of the list is list 4. So we said dot sort. What was this operation doing, dot sort? It was sorting the original list. It was making that change in the original list. And this function sorted was not changing the original list. It was taking the elements from original and making a new separate list. Let's see whether they are going to work here also or not. So first we'll talk about sorted. So I'll say sorted data is equal to sorted, and I will say tuple 5. And when we check sorted data. Now, what can you notice there? That this tuple was taken, which had the data in a very unorganized manner. Now they have been organized very properly in the ascending order. So by default, it will do in ascending order. If you want to do the sorting of the data in descending, what you need to do? Just have to say reverse is equal to true. You just have to switch this thing on. Reverse is equal to true. And when you run this, when you check it, the data will be sorted in reversed order. So what is essentially this sorted going to do? And when we look at this tuple 5, has anything happened to our tuple 5? No, because tuple can't be changed. So obviously nothing will happen to tuple 5. So what it has done, sorted has taken the data from this tuple. It has just taken the element from inside of that, all the 5 elements, arrange that in ascending or descending order, and it gives that inside a list. It will not give us as a tuple, it will give as a list. So it is just the way this thing is created, that is the data it will give. The next one is called dot sort. Is this dot sort going to work? Let's see. Tuple 5 dot sort. No, it is not going to work. Why it is not going to work? Because tuple can't be changed, but dot sort is an operation that tries to change the original data, that tries to sort the original data. So obviously it will not be allowed. So if you have to do sorting of a tuple, you only have this one option using this keyword sort. Next one, the last few things which are left are, if you want to find out the maximum, minimum, these things also you can find. So let me show you. You have tuple. So if you want to find the maximum value in this tuple, you can say maximum of tuple 5. It will tell you what is the maximum number inside. If you want to find out minimum, so it will tell you the minimum of tuple 5. If you want to do the sum of all the numbers inside this tuple 5, you can do that also, the sum of it. So now in here, what we have seen some data in tuple 5. So let's create tuple 6, which has the combination of integer and float values. And we'll try to see whether it happens or not, whether it is going to do the sorting in or not. So I have taken this data, and after that, I'll just put a 50.5, 10.2. Let's see if we have a combination of the data, whether it is going to do that or not. I run this and I say now data is equal to sorted, and I say tuple 6. Let's run this and let's check data. So now what are you noticing? It has been able to do that. Why it has been able to do that? Because you can compare an integer with a float value. The decimal and integers you can compare, but you can't compare a float value with a text. You can't compare an integer with a text. So if you have the text also, integer also, float also, then it will not be able to sort that. But if you have both the numbers, either in integer, either in float, it will be able to do that. So these were all the operations of a tuple. What we saw in tuple, just to give you a brief idea, just to summarize it. First property you should remember, it is immutable. Tuple is very similar to a list. Okay. Tuple is similar to list, but just it can't be changed. So these are the two properties we have seen. And we have seen multiple examples that we can perform on the tuple. We have seen indexing, we have seen slicing, multiple things we talked about. And this is very important. After the session, go through it properly and understand that. It will help you a lot, because Python is going to be very important in upcoming future. So you should give some time and understand that properly. I'm basically covering that in extensive manner for that reason. Now, this was the whole concept of tuple. Now, few minutes we have left, so talk about the another data type, which is called sets. This is also easy, you will be able to understand, but it's an interesting one. Let me explain you what is this sets. Let us talk about that. First thing is, set is a little bit different data. The sets are unordered collection of items. Items means the values. Sets are unordered collection of items. The previous ones that we have seen, the string, the list and tuple that we have seen, they are ordered collection. Okay, list and tuple are ordered collection of items, but sets are considered to be unordered collection of items. What do we mean by order and unordered? What is this going to affect? So when the list and tuples are ordered, we can basically perform indexing and slicing. So ordered means they will be in proper order from index number 0, 1, 2, 3, 4, 5, 6. They will be like that. So we can perform indexing and slicing on an ordered data. But if we have unordered data, we can't perform indexing and slicing on this list. We can't perform. So set is that type of data. It is little unique. The second very important property of set is that it does not allow duplicate values. Okay, it is simply not going to allow duplicate values in single set. So if you create a list like this, you can have 10, 10, 20, 30. You can have a list. You can have the tuple also where you can have 10, 10, 20, 30. But if you try to make a set with these elements, what will happen? Only one time 10 will take, one time 20 will be taken, and only one time 30 will be taken. These are few things you need to remember as of now. Sets are unordered collection of items, and sets does not allow duplicate values to be stored inside of them. Let me quickly show you that whether they are working or not. Okay, and then I'll show you how you can convert a list and a tuple to a set, and what will it help us to do. Okay, now see, to create a set, I'll just say set1 is equal to create a set, you use this flower brackets, this curly brackets which are there. Inside of that, you have the sets. Let me put the values 10, 20, 30, 40, 50. And I'll have 52 times, I have 42 times, and I have 32 times. This is the data. Let me run this. It will not give you any error if you try to have multiple duplicate values inside. It will run very properly. But when you check set1, it will show you that 10, 20, 30, and 40, and 50. There was 2 times 50, 2 times 40, 2 times 30, but it has taken only one time. So it just allows unique values to be there inside a set. It will never allow duplicate data to be there inside a set. So where can you use it? If you are trying to store in the database the username and password. So what will happen? A tuple can have the duplicate username and a tuple can have duplicate passwords. But if you see on the websites, if you're trying to use username many times, you won't be able to use duplicate usernames. Password you can use duplicate, but username it won't allow. It will tell you to change the username since the one you are using has already been taken by someone else. There you can use the sets to do something like that, to not allow any of the duplicacy of the data. That is where sets will be important. So if you're using this Python to create those databases for the website, that is where they will be helpful for you. We'll talk about those examples. We'll try to make a small database like that in maybe tomorrow's or day after tomorrow session, because for that I need to explain a dictionary also. Something is there. So sets. This is the main importance of the set. What did I tell you? That set also has this property of being unordered. We have seen this property that the set will not allow duplicates. Every value is going to be unique. Let's see the second property, that it is unordered. Unordered means I can't do indexing, I can't do slicing. Let us try that. So if I say set1 and if I say 1 means it should have selected this 20. Take a look at this set1. So these are the values here. If I say 1, it should have selected 20 for us. It won't allow that. If I try to do slicing, it won't allow that. So it will just say, no, this operation can't run because the values are not in ordered way. They are not